A car immobilizer is an anti-theft system that prevents the engine from starting unless the correct key or authentication method is used. It's designed to stop hot wiring and unauthorized vehicle use by disabling fuel injection or ignition systems. Modern systems often integrate with keyless entry, remote start, and smartphone connectivity for added convenience. As of 2025, over 90% of new vehicles include factory-installed immobilizers. The immobilizer system relies on a transponder embedded in the car key and an antenna coil located in the ignition switch or steering column. When the key is inserted or brought near the vehicle, the immobilizer control unit sends a radio frequency challenge signal through the antenna coil. The transponder chip in the key receives this signal and responds with a unique encrypted code that matches the vehicle's stored data. The engine control unit, or ECU, verifies this code. If it matches, the engine is allowed to start normally. If not, the fuel injection system or ignition is disabled, preventing the vehicle from operating. The key components of a car immobilizer system include the transponder key, antenna coil, and engine control unit. The transponder is a microchip embedded in the key that communicates using radio frequency signals. The antenna coil, located in the ignition switch, receives and transmits these signals to facilitate communication between the key and the vehicle. Finally, the engine control unit verifies the unique code from the transponder. If valid, it allows the engine to start, otherwise it prevents ignition. Immobilizer systems can be passive, activating automatically, or active, requiring manual input like a button press. Common immobilizer problems include depleted key batteries, especially in keyless fobs that rely on power for communication. Chip damage can occur from heat, water exposure, or physical impact, requiring key reprogramming or replacement. Aftermarket accessories like alarms or radios can interfere with immobilizer signals, causing false negatives. ECU failures or software glitches may prevent legitimate key recognition, often needing professional diagnosis. These immobilizer issues account for 5 to 7% of vehicle breakdowns, according to recent statistics. Modern immobilizers use rolling code transponders that change encryption with each use to prevent relay attacks, where thieves use signal boosters. Over-the-air updates allow manufacturers to remotely patch vulnerabilities, keeping systems secure without dealership visits. Cybersecurity is emphasized with AES 256 encryption for data protection and integration with vehicle telematics for real-time monitoring. Trends include the shift toward digital and biometric keys. By 2025, 40% of luxury vehicles offer smartphone-based digital keys via apps, allowing key sharing without physical devices. Integration with AI and machine learning is emerging, where immobilizers learn user patterns to detect anomalies, like unauthorized entry attempts. Biometric immobilizers using fingerprint or facial recognition are in prototype stages by automakers, projected for widespread adoption by 2030. The Volkswagen Immobilizer scandal began in the early 2010s when thieves bypassed systems in 2009 to 2014 models using inexpensive tools. This led to a 20% increase in thefts, prompting Volkswagen to retrofit affected vehicles with stronger encryption, reducing incidents by 50% after 2015. Moving to another case study. Tesla faced relay attack vulnerabilities on Model 3 vehicles in 2022-2023, where signal boosters tricked the immobilizer. The company responded with over-the-air updates adding proximity checks and multi-factor authentication, resulting in a 30% drop in theft-related claims. Now examining the final case study. Hyundai recalled 2023-2024 models in 2024 due to a firmware bug causing immobilizer failures after software updates. Owners were stranded, but the company provided free fixes and used the incident to improve quality assurance standards across the industry. These case studies highlight immobilizer vulnerabilities and the critical role of rapid system improvements in maintaining vehicle security. Experts emphasize the need to balance security with usability in immobilizer design. While these systems have successfully reduced vehicle theft by 60% since their introduction in the 1990s, with theft rates dropping 40% in regions requiring them, IoT integration creates new vulnerabilities. Immobilizers are only as strong as their weakest link, often the user's connected device. Looking ahead, The future points to autonomous authentication through biometrics like fingerprint and facial recognition, expected by 2030. IoT connectivity will enable cloud-based key management, reducing reliance on physical keys. Enhanced cybersecurity measures, including over-the-air updates and AES 256 encryption, will combat rising cyber attacks. Immobilizer technology continues to evolve, maintaining that crucial balance between robust security and user convenience.